All right, guys, the recording is in progress. Right. Hey, Cassidy, why are you over there? Can we tell her to sit down? No, what's going on? All right, so guys, unfortunately, fellow classmates not here as yet. Right, and we have 2 empty chairs. Right, we're gonna go ahead and start, guys. Right, so you all buckle your seats. It's been 3 weeks, and you guys have learned a lot. Right, you learn a lot, right here. Learn a lot, Sebastian. How about you, James? Right, I know you started a little bit late, but I'm sure that you've been engaged to know that there's these exciting possibilities in the world. And there's so much important reasons why you need to learn today. All right, so you could be a contributor in making a better world tomorrow. Cassidy, how about you? Did you learn a lot? Huh? Tell us some of the stuff you learned about. What did you learn about? How to make a tomato, how to make a smiley face, right? With code, right? How about designing your website, right? Did you learn what is a computer? Right? Did you learn what is hardware and software? Right, Shreya, what about you? What did you learn? How to write your own program, right? How to develop games with JavaScript, right? Sebastian, what did you learn? Very good. That's called ASCII, right? It's essentially the alphabet of code, right? So I'm gonna go ahead and share my screen with you guys. You guys should be able to see. Oh wait, why are we on this side instead of that side? Yeah, this thing is kind of crazy to me. Oh, she get back, right? Very good. So guys, it's been 3 weeks and you guys have done a lot of work, right? So now, right, we're just gonna take a look back at all the work that was done, all right? So that we'll set a foundation for where we're going this week. Okay, guys? So let me go ahead and share my screen, just a minute. Right, so that one is screen number 2, that one is screen number 3. That's okay. All right, here's my pointing device. See if I get my laser pointing device. Laser. Very good. Okay, so the first week, guys, you all learn about computer hardware and computer literacy, right? You all learn what is a computer. We said a computer can be defined based on 4 basic functions, right? Input, output, processing, storage, right? We looked at the first and the second generation of computers, right? And we said that the first generation was as big as a entire room, right? Second generation is as big as a tabletop, right? So that's what we're seeing on the screen here, right? We talk about third generation, right, which is integrated circuit machines, right? Talk about fourth generation and the introduction of the microprocessor, all right? Then we talk about the fourth generation to present, which looks similar to what we're using today, right? You all can recognize the laptop, right, and the desktop, right? You all remember? Yeah? Right. Yeah, so the fifth generation is saying that we utilize the technology of the fourth generation in order to develop the fifth generation. So the fifth generation is artificial intelligence machines. No, holographic is not computers, right? So we're talking about next year. We need coding to make holograms? No, we need hardware first. We have to develop the hardware, which the hardware already exists, okay? There was a rendition of Tupac. You know Tupac? Anyone know Tupac? Right? On the stage as a hologram. Right? There's Waterworld that they have these holographic effects as though there's a real, whale swimming in front of you. Right? They do holograms with cars, all kind of things. Right? So hologram is a thing. But what we're saying is that we need to characterize the computers. We see that fourth generation is what we use in order to develop the fifth generation of computers, which is called artificial intelligence machines. You all see that? So this is the same image, right, that we're using to show that the computers we have today is what we're using to power the development of artificial intelligence. So all that you are learning is preparing you for the future, right? The next era of computers, which is called artificial intelligence machines, right? All right, so you all looked at the different types of computers, right? We have fancy smartphones and tablets, right? You guys remember that? We have laptops, we have very small computers, right? We talk about these microcontrollers, right? The things that engineers are using today. We say that even though you don't know, the car, right? All motor vehicles require computers for the engine to run, computers to deploy the safety bags in the event that there's an accident, right? Computers for the suspension, ABS, all these kind of things, right? So we look at microcontrollers, right? If you all become engineers, you all going to be working with these things. These very small computers is what is responsible for controlling some of the most dangerous processes in the industry, all right? All right, so if we look at this image where we have personal computers, we can see how personal computers have evolved, right? They have evolved starting from what we have in the top right-hand corner of the screen, and you can see how it evolved into what we expected to look like in today's time, right? Then we talk about mainframe computers, right? They are central to the operation of businesses. We talk about Piaco International Airport. So when you go up on the website, the parents, right? Go up on the website and they purchase a ticket. A mainframe is what provides that service, right? They could purchase a ticket and this information is logged. And then they could go, you could print out your booking receipt and they could go and check in when you're ready, right, guys? Right? So mainframes power businesses, right? Very important type of computers that you guys should know about. We talk about the fastest computer in the world. You remember? What's it called? The Summit, right? And it's 200 petaflops, which is 200 trillion calculations per second. We're saying that this computer is so fast. It could calculate the age of everybody in less than a second. Everybody in the world, right? Less than a second, because there's 2.3 billion people in the world. And this thing could do 200 trillion. 2.3 billion people, right? So this million, no. In the world, it's a little closer to that, right? So I would have to check back the statistics, right? But it's closer to 2 point something billion people, right? If there is 7 billion people, this computer still could do it less than 7, right? So that's very good from you, Sebastian. That's really, really good, right? So this computer could calculate the age of everybody in less than a second, right? That's how fast it is, right? Right, so we look at computer hardware, right? You will remember what the motherboard is, right? Right, what the processor is, what the I/O is, right? You'll remember the PCI expansion slots, right? You all remember the IDEs and the RAM, okay? You all remember the CMOS? Everybody remember the CMOS, right? You will look at peripheral devices. A lot of these peripheral devices are inside of the computer, right? And these things was inside the computer, we have the screen in, right? And it was connected to the motherboard via some cables and so on, right? IDEs and so on, and SATA cables, right? We look at other devices. So we have like the scanner, the monitor, the speakers, the printer, the mouse, right? We have the webcam, right? We have the keyboard, right? Sure you guys familiar with that, right? Now, I/O is a big thing. It is what allows the computer to interact with the real world, right? This is how we connect the different devices and expand the functionality of the computer, right? So remember that there's this big chart that you guys have to remember, right? The main things in today's times is HDMI. You all know HDMI? Yeah. Right? You all know USB ports. Not so? You all know the 3.5 millimeter audio jack. That's where you plug in. All right, so let's see if Sebastian's computer has that jack on it. Sure. Right? Your computer should have it. Right there. Right? All these computers have it. Everybody comes to require to have it. Look at this one here. This one has it right here. You see that, guys? Yeah. Everybody see that? Right? 3.5 millimeter audio jack. You all should know these things, right? DVI port. All right. Some of these computers have DVI ports, right? You have computers like that. In America, plenty computers use DVI ports in America, right? Right? You all remember the VGA, using our VGA cable there. This one here for that older, right? Older projector, right, guys? So you all need to be familiar with this diagram, right? Very, 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 very important, right?
My sister, she don't like that. She goes to the factory. She's 21. And when she tried to phone, my son Alice was 20. She asked me that she asked me jacketing. She said the jackets.
Jacketing? Yeah. That's the USB she's talking about. The plug into your phone. Right. So guys, you all looked at repairing the computer, right? Remember you all disassembled everything, right? And you all found out about how to put the processor in the socket, right? How to connect all the peripheral devices in the motherboard, how to mount it in the tower, how to connect the power button, the reset switch, the hard drive LED. You all remember all that, right? So in the event something is wrong with your computer, you guys could pull it down, right? Remove the different hardwares, try to power it and see if it's posting. If it's posting, it can tell you exactly, precisely what is wrong with it. Right? We say the BIOS, who remember the BIOS? Right? Low-level instructions to make sure all the hardware are connected and are detected by the motherboard, right? So you all learn how to repair your computer, right? You all learn how to upgrade the computer too, right? Remember we talk about faster memory, right? Faster hard drive speeds, right? We talk about what? Upgrading the RAM, faster RAM, more RAM. Talk about faster processor, guys, right? We talk about expanding the functionality of the computer by utilizing the PCI expansion slots, right? We could get a GPU, right? Remember we talk about all these things, right? And allow the computer to play, right? AAA titles, which is games, right? Which is very demanding. Most games are very demanding, right? And need extra compute resources to play those games efficiently, right? So we talk about upgrading the computer, right? We talk about what? When we finish building the computer and everything, we have to do what? Format the computer, right? Which is install the operating system, because all the hardware that we have is not going to function on its own. Software right? You all remember that, guys? Software, formatting the computer, right? Installing the operating system. Who remember this? Remember installing the operating system, right? And the instructions that we have to go through after we put that disk in, right? So what is software? Remember we say software is ones and zeros? That's all it is, because computers only speak the language of ones and zeros. We say software is non-tangible components of the computer, right? It is stored in the memory, not so? And that is the instructions that the computer is going to act on. Whatever instructions is stored in memory. And that provides for us everything that you're seeing on the screen there. All the images that we see on the screen, that's what it provides, right? We said it's an organized set of digital instructions, digital ones and zeros, that allows different hardware to communicate, allow the user to interact with the computer, and allow the computer to perform a task, right? So software is so important. Right? When you always writing the code, that is software you were doing there. The computer can't do anything on its own. You have to write the software. Okay? So the computer is as good as the software, right? Remember, guys, the software is an important part of the experience. Right? We talk about the processor. Right? You will see we had looked at a simple single core processor, and we went to dual core processor and quad core processor and all kind of thing, right? We looked at what was inside the processor. We say, if you look at it here, this is called the engineering abstraction level, right? You all might not be familiar. If you look at it like this, you look like a zoo of different electrical components, electrical and electronic components, right? But then over here, there's an image that breaks it down for you. You could see where all the different cores are, right? So we have core 1, core 2, core 3, core 4, right? And we have what? PCIe, which is, right? PCI expansion, right? That's what it means, PCI expansion. Right? We have what? Cache, right? We have I/O, right? And we have the memory controller. So guys, you all remember basic internal components of the processor, right? And we see the difference between single core chip, dual core chip, quad core chip. We have 6 core chips, which is hexa-core. Right? We have octa-core chips. Most of you all have smartphones with octa-core chips, right? And there's even more cores than octa-cores. Right? Very, very fast CPUs that is on the market right now, right? Like the Threadripper. All right, you guys can check out those things, right? All right, so this is the simple design of a processor. Remember, the processor is essentially the most important part of the computer, right? It is what does the calculations, comparisons, right? You say the processor is simply constructed of the control unit, the arithmetic unit, and the registers. You all remember that? So you could tell anybody what makes up a processor. You all could say what? The control unit, the arithmetic and logic unit, and the registers, right? Right? That's how simple it is, guys, that you have to recall. Right? So how does it all work? Remember, we described the whole thing. We say that the ones and zeros, which is the instructions, is stored on this hard drive, right? Okay? So what the control unit does, it fetches that information. That information then migrates from the hard drive into the RAM. And then it's in big portions in the RAM, right? Small portions of what is in the RAM then goes into the registers, right? The control unit then decode those instructions and utilize the arithmetic and logic to do the calculations. And then we get output, and that's how we see the information on the screen. Right? So you all remember all this is ones and zeros, right? So we went to week 2, which was the fun part. In week 2 was fun. Programming and problem solving. We said, since the computer requires software, you all have to learn how to program the computer, right? And you all realize now that the computer has this power, that you have that power at your fingertips and you could use it to solve problems, right? You could write program to solve any problem, right? So we talk about ASCII, which is how you always introduce, right? One student said it is the alphabet, right? A binary, it's a binary alphabet, right? And similar to how we have the alphabet, right? When you are learning English language, right? Then we explored this using the color wheel, the physics color wheel, right? So you remember when you wrote your code for the first time, right? We use the what? The additive color wheel. When we add green and red together, we get yellow. So you remember that? Right? And when we add green and blue, we get Cyan, right? When you add cyan, right? When you add all the colors together, we get white, right? Likewise, when you add red and blue, we get magenta, right? That looks like that, right? You're going to be interacting with the subtractive color wheel, right? When you all get to higher level of studies, right? So we talk about the prism, you can see white light being separated into all the components that we have here. So these are called the primary colors. And when the primary colors mix, yellow, right, cyan and magenta are called the secondary colors, right? We can continue to mix the secondary colors together, tertiary colors, and so on, right? All right, so coding your physics color wheel. You all remember this one, guys? And coding the ASCII. So you can see, this is, here, we have a style tag, and you all remember that? When we set up our web page, we have a style tag, and you can see the RGB, right? So we can choose what portions of red, green, and blue we're gonna assign to create a color. Right, guys? See if you understand, Sebastian? I said this is everything that you guys have done, right? What about these? Who remember these and number sign 84? This is ASCII, and this was what? Tree. This was spelling tree, T-R-E-E, using ASCII. You remember that? And then we use this CSS, this style sheet, in order to style these letters that we were printing on the screen on our web browser using ASCII. All right, so we said there's different generations of programming, right? I'm sure that you guys will remember that, right? So the first one is machine language. And this was hard. Can you imagine you had to remember the ones and the zeros for yourself? All them ones and zeros, 1 1 0 0 0 1 1 1 1 1. You had to remember that to program the computer. That's crazy, right? So somebody did the hard work and they say, listen. Question, Sebastian?
So, if you want to put something by yourself, right? And it's a teacher, how do you get inputs?
Are you getting good?
Yeah.
Well, that's why you have to learn before you attempt. You can't do what you don't know how to do. So that's why you're here to learn it, right? So when you master it now, you could code everything for yourself. What? Okay? These things on the screen? Somebody else did this. So that's what we're discussing now. We said that in the first generation of computers, they had to know the literal ones and zeros, okay? Again, what? Ones and zeros?
No, that's on the screen.
What on the screen? This?
Yeah.
This is ones and zeros. This is what previous generations of programmers had to use. Ones and zeros. We don't use this today. We don't use it.
How do you get that? Like, do you research, you know?
Yes, you could research the ones and zeros if you want, and what they mean, right? So in today's times, we research, for instance, assembly language. You could go and research what these things mean in ones and zeros, which is called hex. This is hexadecimal, right? So you guys can research the instructions and see what is their equivalent in hexadecimal. Right? You all could go and research that, right? So we were saying it's very hard to have to remember the ones and zeros. Somebody did the work and said, listen, future programmers should not have to go through all this hard work just to program the computer. We need to make it easier to program the computer. So they built assembly language, right? So you start to see these procedures: begin, pause, like instructions for the computer, right? Move, right? Reset, end, add, subtract, jump, right? This is assembly language, right? Which is second generation computer language. Then we have the third generation computer language. Look at it. So it starts to look English-like, right? So this is what we call the introduction of high-level programming languages, right? And you all know this stuff here, right? Right? This is code that resembles the way we speak to each other, and it's machine independent. You don't need to know nothing about the ones and zeros to code. All right? So that's it. You all are being taught how to code in high-level language. So you all don't have to know anything about ones and zeros, right? Because there's software that does that for you. You code like this, and software converts it to the ones and zeros, right? That's the Dev Pascal and the who remember the code blocks? Who remember that? Right? Who remember the Visual Studio that you all were installing? Right? You all remember the Visual Studio? Right? So there is these software which are responsible for converting the high-level language when you code into the ones and zeros. So you don't have to know the ones and zeros, okay? All right, then they didn't stop there. They say, you know what, let's continue to improve on it. And they made 4th generation computer languages, right? Programming languages, right? Which this language focus on database, report generation, and website development, right? And we can look at the examples, Cassidy. We could look at the examples, right? SQL, Focus, MATLAB, Accelerator, and so on, right? The 3rd generation programming language is what you guys learned, right? You guys learned C code, right? Remember that? You all learned Java, you all learned Pascal, right? There's plenty more where that came from. Python, Basic, COBOL, Fortran, Perl, etc., right? Right, so the important thing is that you guys were introduced to that, some of the main things. Right, so we started Pascal. Why? Because the traditional secondary school system, this part of the world, teaches you guys information technology. And information technology, when you all get to secondary school, you're all going to be doing Pascal, which means it's important that you all master it from now. So when you all get there, you all could, right, excel at IT, okay? So Pascal programming, we said that you have the title, we start the program, and this is the body of your code. This empty read line is necessary so that you can interact with the output. You all remember that? Every time we type in Pascal code, we have to put the empty read line. All right? And then every beginning must have an end. All right? This is the body of the code, right? It must begin somewhere and it must end somewhere. Right? All right? And then we did our first algorithm. Who remember this? Remember typing this for yourself? Right? You all remember that we had some numbers, number 1, 2, and 3, right? And they were data type integer. Right, we had some average product. And what we did was ask the user to enter these numbers. And when we got the numbers, what did we do? We calculated the product, the sum, and the average. And we printed for the user. We print all them things to the screen, right? So we could see this is where we printed the average to the screen. And this is where we printed the product to the screen, right? And on top here is where we printed the sum to the screen. And you can see where we did all the calculations, right, guys? This is where we calculated the sum, right? This is where we calculated the average. This is where we calculated the product. You see, guys? So I'm sure that you all should remember that. And we said that since you all learn this problem-solving process, you all should be able to write a program to accept 2 integers and find the sum and make that sum available to the user, right? So you guys remember what an algorithm is? It's a step-by-step process. If you are given a task, it's a step-by-step process that can be employed, right, in order to write code that is a solution to the problem you are given, right? So we said, if we're going to do that, what we need to do, prompt the user to enter the 2 numbers. Then we have to save the numbers. Then we have to do the addition, right? Then we have to print it to the screen, right? And you guys did that. So we talk about what is called a pseudocode. Pseudo means likeness. It's not exactly code, but it looks like code. Right? It makes it easier. If you write the pseudocode, it makes it easier to go from the pseudo to the actual code. You follow, guys? So we said this is the pseudocode for the task that was given on the screen. So the pseudocode here, guys, right? We take the numbers, right? These are the variables that we're going to have, number 1, number 2, and sum. We're going to begin, right? These are the things we're going to be doing, right? We're going to ask the user to enter the first number. We're going to read that first number, right? We're going to print, okay? To ask the user to enter the second number. This is a prompt, right? So we're going to do some math, and then we're going to print it to the screen. Right, guys? All right, so writing code in C. You remember when we did these C code in code blocks? You all still have code blocks on the computer, right? You all could develop anything, right? Right? Is there any software on the computer you like? Right? How about the calculator app? Huh? How about the calculator app? What software do you all use on the computer? You all use the browser, right? You all play games on the computer. You don't play games on the computer? Who like music? Who like music? Watch videos. Right, who play music? All those are softwares. You all can write the software for yourself. Right? That is what this is supposed to do, to lay the foundation and set the precedence for you guys. That your growth is accelerated. Right? And by the time you're all 14 years, you all can write these things for yourself, right? Right? That is why you're being exposed to it now, right? Children, other places in the world, at 4-year-old, they're doing this. 4 years, who have a 4-year-old sister or brother, 4 years of age, you're doing the same thing that you all do now. See what I'm talking about? 4 years of age, you're doing exactly what you all do now. In some instances, even more advanced. Right? Look at that. So this is what I'm saying, guys. Right? This is what is happening in other places in the world. In India, in America, in England, right? In Australia, right? And you guys are at a disadvantage. And that's why we must bridge the divide, guys, Sebastian, right? And we must, right, get you guys exposed so that you guys can complete in the future, right? Because you're all at a disadvantage, right? That's how important this camp is, right? This camp is accelerating your growth so that you guys can complete, right? Internationally for jobs, right? And you all could stay here in Trinidad and you all could be the pioneers of the future because you all have these skills to do so, right? All right. Writing your first program in JavaScript. You remember when we did this? Eh? This is the smiley face, guys. You all remember this? So the smiley face, right? So we said embedded in the browser is a method to handle JavaScript, right? So you can see where your program goes and you all could use these functions in JavaScript. Where these functions located at this source, right? So you must remember how to insert the source. You all must remember this as a blueprint. If you all want to code in JavaScript, anything you want to do, you must remember this blueprint. If you don't have this blueprint, you can't do nothing. Guys, make sure you all have this blueprint, right? Have it saved somewhere on your computer, right? Otherwise, you will not be able to replicate nothing that you learn. All right, very important, right? So, writing your first code in C++. Which one of you all downloaded the Visual Studio? Anybody finished downloading the Visual Studio? Nobody finished downloading Visual Studio, right? So this is how you write your first code. Visual C++ is similar to C code. You all learn C code. C++ is similar, where we have libraries, okay? So you must include the IO stream, right? And that allows us to do output on the screen and to accept input from the user, right? So it's very simple. Remember, we have a main, our code have a main, and we have these open and close curly brackets to be symbolic of the beginning and the end, right? So you all learn how to code in C, and then this is C++. All right, guys? This / and n is so that the cursor moves to a new line after the processor executed that line of instruction, right? So guys, please, right, try this on your own. I implore you guys, right? You're gonna be the prodigies in Trinidad. You're gonna be a little older than other prodigies in the world, but that's okay. A prodigy is any child, right, who is so advanced in their knowledge and the skills that they are doing things that adults don't even master. That's what a child prodigy is. And the things that you all learn here today is what university students have to be grappling with, right? The first few weeks of class, right? Things that you all learn there, right? High school children don't even know that, okay? You all learn the whole 9 yards. That's why this is so important, right? So we're moving away from C++ and we're talking about Python. Python is our next programming language, right? This is what especially the computer vision engineers utilize. I'm a computer vision engineer, right? I'm a computer vision pioneer, right? And this is very important to me, right? So in Python, this is how we accept input. We say num1 is equal to input, and this is where the number goes, right? And num2 is equal to input, and this is where enter the second number, right? That is how we do it in Python. So we can accept input from the user and store it in num1 and num2. And then this is how we go ahead and do the addition. We say sum is equal to float num1, float num2. Remember, those are data types. Right, guys? We can display the information on the screen in whatever format we desire. right? So guys, you all should write this down too and check out Python. Everything that you all did in Pascal, in C code, in C++, try and replicate it in Python. Right? These are the skills that engineers have. And you're essentially getting the same skills at a tender age. How old are you, Sebastian? 10, right? And ain't you code all this for yourself? I'm saying, the skills you learn in class, right? All right, the skills you learn in class, you could use it, right? To your benefit tomorrow, okay? All right, writing code in SQL. Who remember SQL? SQL is a 4th generation programming language, right? Deals with database and web development. Ain't you always designing websites last week? Yeah, ain't you all design website last week? Remember the Roblox website? Just now we're gonna get to that. SQL, right? You can see SQL is important for when you're doing web development. There's 2 phases of web development. There's the front end and then there's the back end. The back end is what requires PHP and SQL and so on. So guys, you all must know about this programming language, SQL. You can check it out, right? I'm going to leave some sources with you guys. Right? So you can see we can create a table to store everybody who is a person. And the table will have these things: person ID, last name, first name, the address, and the city that the person is living in. We could create a table and so on. So when you come to my website and you put in your information, that information goes straight to the table. Right? Sebastian, when somebody comes to your website and they put in information, this code, put it in the table, right? Create the table. The table is created, right? And there's a code which is responsible for adding each entry in that table. You guys gonna be able to do that, right? All you have to do is just take a look at it, right? All right. The 3rd week is what we just concluded last week, which was the web and app development. You all could see what is happening here. HTML. You all know the popular ecosystems. Somebody inside here might have an Apple phone, somebody might have an Android phone, right? These are all the smart devices we have. And when you code your website, right, it's going to be displayed on the computer, it's going to be displayed on the tablet, it's going to be displayed on the smartphone. Look at what's going on. Computer, tablets, and smartphones, right? You see it? Each of them is going to be able to decode the HTML and produce what is on the screen, right? And then app development. Right? App development, this is Java here, right? You all can see what's going on. App development, this is exactly what you guys did, right? So let's take a look at what was done. Web development, right? We need HTML. Ain't you all master HTML by now? Remember HTML tags? This is how we code the website, right? PHP, jQuery, JavaScript. Remember when we developed the games in JavaScript? Tic-tac-toe and so on. JavaScript is what we used to do that, right? Right, so this was our first web page. You remember our first web page? Huh? Right, this is the code that we used to do it. Document type, right, at the top of the notepad. You remember that? Then we have the HTML tag. Anywhere we open a tab, we must close the tab. So HTML tag. Then we have the head. What goes on into the head? Title. This is where we do the web development. Look here, marks web. Right? This is where it marks, right? Right here. This is where we put that information in, right? Then we have the body. So the body is where everything is going to be on the page. And you can see our web page, right? We use the paragraph tab in order to enter, right, that text on the screen, right? We format that text and we set it to align to the center of the screen, right? So you guys remember how we did the first web page, right? Right? Now, why you are learning all this? How to get your business online? You all gonna be, right? The minds, the brains, the skills, the expertise to get the businesses in Trinidad and Tobago in the future, near future, online, and you all get the skills to do it already. What do we need to put our business online? We need to register the domain. You all remember when we went to GoDaddy, HostGator? Who remember these things? Right? Cassidy. You know, we went to GoDaddy and HostGator, right, to register the domain. And then what we have to do after? Develop the website. You all remember when we code the whole thing? The Rubik's Cube, right? And we code the whole website. You all remember that? Right? And then we say what comes after? We need a server. The server is where we're going to upload, right, the website that to the internet, right? Then we need to maintain the website from there. And social media is a big thing in today's times. So there must be some sort of social media integration, right? So that social media users can interact with your website, right? Very important, right? Right. So registering the domain. Remember, there was plenty options: Squarespace, GoDaddy, HostGator, Amazon, Google. You remember this? These are the providers of domain names. You could go to them and you could purchase a domain name. Remember that as the first part of setting up your website. All right? So we did that process, didn't we? Right? And we talk about the parts of a URL. URL means what? Uniform Resource Locator. And it has different parts. So HTTPS is the protocol, right? Here it is referred as the scheme. Right? So ours didn't have, but this one has it. There's subdomain. Right? Sub-level domain and top-level domain. Right? So all this here, from here to here, is called the domain name. Who remember that? We did it for our Rubik's Cube website, right? And then this subdirectory is called marketing, right? So the directories is what come after with the slashing. Let's take a look at the Rubik's Cube website that we did, guys. You all remember this? Right? This is it. So this is the protocol, hypertext transfer protocol secure. Then we have www. What is www? What is www, guys? Yeah, Sebastian, remember. The World Wide Web. Very good. The World Wide Web. The World Wide Web is the what? The publicly accessible part of the internet. Everybody have access to it. So we could go and we could see the information that is there. This is where the search engines pull the information from first, right? Okay, the World Wide Web. So your website, you want anybody in the public to have access to it. So it's going to be a part of the World Wide Web, right? Remember we talk about the .com, the commercial part of the internet, right? We have .edu, right? We have .tt, right? You remember all that? Yeah? We have .net. We have .tv, right? You remember the early history of the internet, the military, right? And how the internet is what? The largest network of computers in the world. In the world, your computer is not connected to that network, right? My computer is connected to the same network. Everybody, wherever it is in the world, when they connect to the internet, they are connecting to that network simultaneously. Everybody's computer is connected. Guys, you're seeing that, right? And this is what the privileges that we are living today because the internet is so important, right? Especially the publicly available part of the internet. Remember we talk about the dark web, right? Which is not exactly publicly accessible unless you have the knowledge to access it, right? So this was our Rubik's Cube website. So we went to GoDaddy and we buy the rubikscube.com. You all remember that? Yeah? We buy that domain and then what we do? We code our website. Guys, you all remember that? We say we go and sell the Rubik's Cube. And how much different types we have? We have the LED one, we have the Bluetooth one, we have the robot one. You all remember, guys? Yeah? All right, this was the code. Who remember this code? Who remember that code? Anybody remember that code? Eh? This is the same code that you all typed. This is the code. Welcome to the Rubik's Cube Corporation. The history of the company, right? We created that in the summer camp, right, guys? You all remember writing this code? You all write this code for yourself. Then the collections that we have for sale, right? The LED one, the Bluetooth one, right? And we have the robot one, right? And then we implemented our WhatsApp button that they could message excellence mission. You all remember? So if you all have a WhatsApp for your business in the future, your business is gonna have a WhatsApp for sure. Right? So you need to code the WhatsApp on the website that somebody come on your site and click and message you immediately on the WhatsApp. You follow that, guys? They could send you an email, rubikscube.com. Right? Remember, we purchased that domain. So because we have the domain, we have email attached to it, right? So we have email services. Okay, guys? Right? So this is how we coded the Rubik's Cube website. All right, let's go to the next stage. Drawing with JavaScript. The first thing we did was draw the smiley face. You all remember the code for that? Eh? You remember that? we do the tomatoes? We buy the tomato and all, right? Right? Coding the 3D box. Remember, this was a lot of code. So you guys took a look at it, but you didn't try to replicate. Okay? There was a lot of code. Right? Now we could draw things like sunflowers and roses. Which one is the sunflower? The yellow one is the sunflower, right? So this one here is the sunflower. And which one is the rose? This one here. Nice to show you guys that you guys can distinguish which is which. Right? So JavaScript is powerful in that we could draw anything on the screen, right? Check out this one. What's this one? We could simulate real world behavior using JavaScript. That is why the games we have today is so real world like. If you want to play games with a real human, somebody looking like a real human being, bending down in the bush and fighting monsters and shooting gun and flying, craft and all kind of thing. Huh? Right, guys? Simulating the real world. Look at that. What is that, guys? A drone. If you all have the programming skills, you all could do that for yourself. Ain't you all see the code for the bouncing ball? Ain't you all see the code for this bouncing ball here? Not so? I'm trying to get the bouncing ball to play again. Right. Right, but you all have these, if you all have these skills, you all can code this for yourself. Not so, guys? Yeah? Exciting possibilities, and with the skills that you are learning here. Right? What's next? Game development with JavaScript. Let's take a look at it. Look at it, guys. This was the rabbit game. You remember it? Which rabbit is gonna win? Which rabbit is gonna win, guys? Alright. The second one wins, right? What about the TikTok game? If you all code this for yourself, you all wrote the code for this. Who's gonna win? The person with the X's is gonna win, right? Because he could win here or he could win up there. You all seeing this? You all coded these games for yourself. You all, after you finished coding the game, went home, right? And play with your friends and your family. Sebastian, you get them licks? Did you get them licks? Well, right, that's what we're talking about. Cassidy, you get them licks? Who you play with, you get them licks, then? Well, right. Right? So game development with JavaScript, right? All right. So last week is done. And this is the fourth week, the fourth and final week. Everything that you all learned before was preparation for this week. This week is the biggest and brightest ideas that is happening in the world right now that you're all going to be learning. You're all going to be exposed to it. Right? What do you all think is the biggest and brightest idea in the world by looking at what is on the screen? There's no games on the screen. Try again. Robots. All right. The internet, I will accept that. What else is on the screen, guys? Brains. That's good. What else is there? You all seeing this? Artificial intelligence. Artificial intelligence. Remember, I made a reference to that before. He said that is the fourth generation of computers we are using the power, the development of AI. Right? And you all see it coming back. Artificial intelligence machine is going to be the next era of computers. Right? And we're trying to prepare you guys for that era. Right? In order for you guys to be prepared for that era, you all need all these skills long before it comes. Right, guys? That's why you are learning all these skills, right? So, intelligence is such a big word. Who think they know what intelligence is? What is intelligence? Yeah? Smartness. That's good. What's intelligence here?
Great. Learning to share.
What's intelligence? Right, the mind. Right, James? What do you think intelligence is? If somebody tells you you are intelligent, you're a very intelligent young man. Right? What is intelligence? What do you think intelligence is?
I have an answer to intelligence.
Intelligent. Thanks for the correction, Sebastian. Right? You're an intelligent young man. What does it mean, James? Do you have any idea? Cassidy, you want to help him? Right? You could use your brain a lot, you see? In order to talk about intelligence, the human anatomy has to come into play. The brain, right, is possibly the single most important part of the human body. It's debatable, but I'm saying possibly the most important part of the human body. Nobody could function without the brain. If there's an accident and something happens to your brain, right, that's it for you. You disabled. Alright guys, so we don't want anything to happen to your brain. There have been people in accidents and something happened to their brain and they can't remember nothing. Hi Sebastian, nice to meet you. Nice to meet you, and then 2 seconds after they say, hi Sebastian, nice to meet you. They forget they introduced themselves to you already. You all might have parents with Alzheimer's. It's a horrible disease, right? You could imagine you live with your auntie all your life, and then your auntie wake up one morning and say, who is you? And you say, auntie, it's me. It's bald head. And auntie say, mommy, you know you. Yeah? And every day, auntie wake up and you have to remind auntie who you are. Right? That's how important the brain is to intelligence. Right? So you all answer the question of what is intelligence. How are human beings intelligent?
Because they went to school. No. Because.
Right, that's a good answer, Shreya.
Because human beings have the biggest brain of all.
Right, our brains are somewhat larger than the other animals in the animal kingdom, right, guys? That's a very good answer, Sebastian. Cassidy, what about you? How are human beings intelligent? Because we use our brain. But not only that we use our brain. Guess what? The brain is enclosed inside the head. It's protected by the skull. The brain gets information from the eyes, the mouth, the nose, the skin. Yes, the mouth is where your tongue is. And your tongue is what tastes the food. And that's how the signal is communicated from your mouth to your brain. Alright, so the brain is enclosed because it's very sensitive, right? Right? The human bodies have evolved to protect the brain. Okay? And the senses that we have. Did everybody know sense?
Yeah.
What are the 5 senses? Taste, smell, hear, touch. Right? Sight, right? Very good. So all those things work because what? The brain. Alright? We have the eye. The eye see because the signals are being sent to the brain. And the brain is what is working here. So that we can see what is in the room. The eye is getting the information. But that information is not the experience. That information goes to the brain. And then the brain creates the world from on the inside. Right? Okay? Right? When I say something, you are hearing it. Because the ears is responsible for communicating the signals to the brain. Right? Likewise, when I touch it, you feel it. Right? But question. Who knows how the brain works? Anybody know how the brain works? Anybody think they have an idea how the brain works? Right. Different parts of the brain. There's a part of the brain that is responsible for seeing. There's a part of the brain which is responsible for reasoning and interpretation. Alright? And one of the most important phenomena that happen to human being lives is called language acquisition. When you are a baby, right? And your father and your mother and your brother and your sister kissing you up 1,000 kisses and talking to you and say mama, say dada. What is happening is that your brain, right, is growing and you're learning language. You're learning how to speak. Sure? Right? You are a baby, but okay. No problem, right? So language acquisition, right? That's when the brain was in its prime and you all learn language. Get this. If I talk in that baby, I go talk in English, right? I go say, come on, child. Say your father's name, say your mother's name, right? But somebody in Spanish go do what? What they would say? Eh? Padre, Mama, right? Nina, Nino, right? Right? These are the things that they would say. So you could imagine, right? Family that speaks a different language communicating to a baby. The baby is deciphering what the words mean. You follow it? And that's how the baby is going to learn how to speak Spanish. Somebody in France talking to a baby. Bonjour, right? All these nice things they're going to say, right? I don't know French, right? But the baby is going to be deciphering that and going to be learning how to speak in French, right? So we see how the brain is so powerful, right? So if we decipher how the brain works, do you think we could create a software version of the brain? Who think we could create a software version of the brain? Sebastian? The brain is so powerful. What if we create a software version of the brain? You sure? Now the computers will have a brain. Computers have memory, they have processors, they have all kinds of things, right? They have software, right? But up until this point, they don't have brain, right? What if we could, from how we understand brain, right? We could program a software replica of the brain. What if we could do that? All of a sudden now, the computers are gonna have human-like intelligence, right? So you all see where the artificial intelligence coming from? The computer could talk, yeah? The computer could see, yeah? Well, you have to program that. You have to program the computer to taste. Alright? So guys, this is how the brain ticks. I'm going to teach you all something important. This is called a neuron. Alright, this is how the brain works. So, the brain is electrical stimuli. Okay? And what happens is that we have these receptors in the brain. Okay? These are receptors here. Right? And those receptors, the electrical signal is sent, and if that electrical signal, right, meets a minimum value, then the neuron is activated, and then what happens? It then sends synaptic signals to other neurons and cause other neurons to activate. So what is happening is that the signals from the real world that is coming in from the eyes and the nose and the mouth and the skin, right? Those electrical signals is going to different neurons in the brain and switching on those neurons and those neurons switching on other neurons, right? And at the end of it all, that's how we see, we feel, we taste, we smell, we can touch each other, right? Any questions?
And you want to go and tell something or do something, go classes and fire, set up on us, place a hunt, and then when you reach the destination, they teach you there. Why is that?
Just forget, right? Because we have long-term and short-term memory. And you have to train yourself. You have to train yourself and practice remembering for the long term. That's what education does. It's training the brain to think and to remember the important facts of life.
Why sometimes?
Sometimes because everybody is different. It depends on how much training you have given your brain. If your brain trained properly, it will remember. Someone else's brain is trained properly and they wouldn't forget. You tell them one time and they remember. Tomorrow they still remember. Next week they still remember. Because their brain is a little bit more trained than yours. Training is important. And you're going to see the same thing in the software, right? You're going to see the same thing, right? So these are the neurons. Watch this now, guys. Simulating the brain in the real world. Simulating the brain using software. Creating a virtual replica of the brain. So much so that computers now could have a mind of their own. Could have a brain of their own. And we could describe the computers as now being what? Intelligent. That's why the next generation of computers are going to be called artificial intelligent machines. Artificial because what? They're not flesh and blood like us. They're physical hardware. So we call them artificial intelligence. Question.
Robots, right? In halfway there now, and sixth generation will be
we're not sure. We just know that the fifth is artificial intelligence machines, right? Right? We will see what artificial intelligence machines do, right, to usher in our sixth generation of computers. But for now, I wouldn't be in a position to guess what that is going to be, right? So look at it, guys. Check it out. If we do that virtual replica of the brain, it's going to be very hard, right? There's more connections in the brain than there's stars in the universe. Stars in the galaxy. Guys, there's plenty connections, you know, like plenty neurons in the brain, you know, right? It's hard for me to code a trillion neurons. But if we have the Summit computer, and we could code a trillion easy, and I could code 200 trillion around in a second. So you are seeing why artificial intelligence requires very fast computers, right? You are seeing that, guys? It's not easy, right? Now check this out. This is a symbolic representation of how we code, right? A neural network using software. So in the brain, there's a network of neurons in the brain, all of them connected some way, somehow, right? And if one is activated, that one could activate others. And that's exactly what we're trying to replicate here, right? We might not be able to replicate as much neurons in the brain, but we could get close. Or we could do something mediocre and see how it works, right? So check this out. We have the input layer, right? So this layer is going to accept input coming from the real world, right? Or coming from other software, right? And what happens? If the input is good enough, right? It's going to activate, and then this neuron now could activate other neurons, and those neurons could activate other neurons, and those neurons activate other neurons, and so on, until we get to the output. You're seeing it? Share? Very important stuff. You're seeing it? Right? So remember, the idea is to do what? Replicate brain using software, right? Software is so important, right? Remember, with the right software, you can do everything, right? So that's why we develop the brain as a software, right? You think you all could do this? You all think you all could write the code for this? Huh? You all think it's gonna be hard?
Yes.
All right. Right? It's gonna be challenging. Huh? So check this out, guys. The greater the amount of network of neurons we have here, right? We call them deep neural networks, right? Why? Because there's so much more neurons inside here. The more layers and layers and layers of neurons we stack together, we arrive at what is called deep neural networks. Right? Question. Ready for the question? We're ready for the question. When a neural network has plenty layers, what do we call it? Deep neural network. Right, guys? Sure? When a neural network has plenty layers, what do we call it? Deep neural network, right? All right, that's it, guys. We have reached the end of the slide. Okay, and I need you all to take a quick break. Right, get us up, right, and come back to be refreshed. Go ahead. Right, we just reviewed everything and we laid the foundation for what we're gonna be doing next. Right, so go on a break. Take a look.
It will actually consist of probabilities for cat or dog. So it may assign a 75% probability to the image being a cat and a 25% probability to the image being a dog, meaning that the model assigns a higher likelihood to the image being a cat rather than a dog. In this case, the loss is going to be the error between what the network is predicting for the image versus what the true label of the image actually is. So it makes sense for SGD to try to minimize this error to make our model as accurate as possible in its predictions. So after passing in all of our data through our model, we're going to continue passing in the same data over and over again. Now, during this state of repeatedly sending the same data into the model is when the model will actually learn. So through some process that's occurring with SGD repeatedly, the model will learn from that data and then update the weights of the model accordingly. So what does it actually mean for the model to learn? We're going to pick up with that topic in our next video. So we know now generally what's happening when one passes the data to the model. In the next video, we'll see how the model learns through multiple passes of the data and what exactly SGD is doing to minimize the loss function. Also, before wrapping up, I did want to point out that I just generally covered the optimizer, loss, and a couple of other topics in this video. We'll definitely be going into more detail about these topics in subsequent videos, but I just needed to give them a general introduction here so that we could understand the basics of training. So hopefully now you have a general understanding about what it means to train a model and how this training is implemented. Stay tuned for the next video where we'll learn what's happening behind the scenes in this training and how the model learns from this process. I hope you found this video helpful. If you did, please like this video, subscribe, suggest, and comment.
Guys, close the door. Close that door. see if you can control them back there from. Nah. They get a little break now because it's plenty now. right, guys. It's time. Sit down. That's not you will finish.
You didn't draw that. I said it was the picture. Will you see that again? No. I see it. You couldn't draw something like that. And I see you. So, yeah, it's.
You all eat too much snack? You all eat too much of snacker? Oh Lord. Sebastian, you can't do magic.
Let me show you how to do magic. You see that?
Alright. Alright, your magic trick doesn't work, Shay.
That is stupidness.
Alright, guys. Sit. Let's go. Alright, so you all have no excuse. It's a lot of things you are learning. Right? So you all get a break, right? You all needed a break just now, right? Right? So you all refresh and you all could come back at it, right? So we say human beings intelligent because they have a brain, right? And they didn't born intelligent. They started out a baby, right? And the brain had to grow, right? Not so? And that's how they learn, right? So somehow, when we're growing up, the brain is undergoing training, right? Yeah? And since the brain is so important, remember with software we can do anything. So we say what? We're going to make a virtual replica of the brain, right? And so on, we can simulate the functions of the brain in our software, right? And we said that we will set it up just as how we have the neurons in the brain and so on, right guys? When I get my point, I did quickly. So we're saying here that we have, these are neurons, right? You remember what a neuron look like? This is a neuron here. But this is our software replica of a neuron, right? So our software replica, right? So you could see it here, guys, that this is the head of the neuron, and then this here now is the synapses, right? So take a look at it. Likewise, this is the head of the neuron, and then these lines running from the neurons is called synapses, right? Synapses, okay? So you all know synapses, right? You all know that we have neurons with synapses and all of them connected to this giant network, and we can start plenty of them. When we start plenty of them, we call it a deep neural network. You all remember that? Deep neural network. All right, so now we have an infant brain. What we do with infants, they gotta grow, right? They gotta learn, right? So we have to train the brain, right? So the next step now is training the baby, right? Can we train the baby? Right? The baby will learn how to play with this and this, make that noise and shake up this thing and spin that and the turn, right? That's how the baby learn, right? Just as how we train our baby, guess what we gotta do? Train your network. So watch this. We need to train the network to know what a cat is. So what we do, we train in a supervised way. We say, hey, this is what a cat looks like. And we provide 1,000 images of cats, right? All the different types of cats. Cats with their hair, with their fur long and the ears long, so and the head big, all different kind of cats, right? We provide those images to the network, right? And what happened, as it streams through the network now, the behavior of those synapses are changing. You can see how it's changing here, right? Everything inside the network started to change, right? Right? And then at some point in time, guess what? It says, I'm ready. I'm ready. I now know what a cat looks like. That's how easy it is. Right? We set up, right, a virtual replica of the brain, right? And we teach it something. We say, hey, this is what a cat looks like. And we feed it through the network. When we feed it through the deep neural network, what happens as the cats come streaming in, right? The behavior of these lines and so on is modified, right? And at some point in time, it reaches a configuration and it says, I am ready. I now know what a cat looks like. So here what we want to do. We want to test it to see if we really know what a cat looks like. You ready? We want to take a picture and the cat that we have home, right? And we're going to feed it to the neural network. That's the cat that we have home, right? Feed it to the neural network. And what the network say? Yes, this is a cat. The network say, yes, it is a cat. You see? The network now knows what the cat is, right? And can identify a cat. You see it? Hey, what if we try to trick it? Get a dog instead. You think it can distinguish a dog from a cat? It only knows what a cat is. We never train it to know what a dog is. I said, let's give it a dog. Voila. And what does it say? No, this is not a cat. So it knows what a cat is, it knows what a dog is. If we could train it to know a dog, right? If we could train it to know a human being, if we could train it to know a car, right? It's so complicated today, science, that we could train it so that the car could drive by itself. Which of you all know about Tesla cars? It could drive by itself, right? You could train it to know, look, this is the road, this is the lane, and it's stay in that lane. For itself, you don't drive again. Autonomous cars. So what is making the cars autonomous? Artificial intelligence. And artificial intelligence is what? It's just a virtual replica of the brain, right? And we train that brain just as how a baby train, right? And we get it to know what stuff is. Okay? Now, there's two types of AI, and the one you all are introducing today is called classification, right? This is how we classify something, right? So we classify a dog different from a cat. So the network knows what a cat looks like, right, versus what a dog looks like. So if we send some pictures to the network, what? The network will know, hey, this is a cat, that one is not a cat, right? But if we train the network to know every animal there is, every single animal in the animal kingdom, would you all want to be a part of that? Eh? Let's say Google have an AI, and they're training that one central intelligence to know every animal in the animal kingdom. So you dive in, and you see a fish, take a picture of the fish, and you say, but you know what this is, you know? You go up on Google AI and you submit that picture, and Google AI tell you, hey, this is so and so fish. Because it knows, it received the training to know every type of animal there is. What if we train that same AI? Not only to know every animal, know every plant. Hear how crazy it gets. Everybody training to know what everybody looks like. Because the information is already available online. Right? The computers already have what we look like online, and our name, and our age, and where we live in. So what if computers are being trained right now to know what everybody look like? So when the robot walk past you on the street, they say, "I share," and you start the ball. Oh, this robot know me. Yeah. Right? They don't know me, you know that. Say, "Hey, Sebastian." Right? We're going on there. You start the ball, right? All right. So we've reached the end of today's session, right? And you are supposed to be excited about the possibilities to come back next day. And despite how hard the programming might seem, we're going to make it as simple as possible for you guys, right? Start doing some AI for yourself. When we've done the AI now, what part you all want to know about now? The robotics, right? So be inspired. Go home, watch some videos, talk to your parents, tell your parents, "Hey, mommy, I get to understand, it's possible that our computer is being trained right now to know everybody, right? Because all this information is publicly available on social media." Hear this. Every one of us have a cell phone, eh? Yes, you have a cell phone, Sebastian. You have a cell phone. You know your voice. Do you know your voice is distinctive to you? When you speak, Sebastian, nobody does sound like you. Nobody who has ever lived and will ever live will ever sound like you. What? Your voice is a biometric system. It is distinctive to you. So when we talk on the phone, if our calls are being recorded, a computer could be training right now to identify everybody by voice. So when we speak, the computer say, "Hey, that is Michael." When you talk, the computer say, "Hey, that is James." Sebastian, you say, "Yes, that is Sebastian," because the teacher in class. And you go home and say, "Mommy, that wasn't me." But then they play the recording and the computer say, "Yes, it's Sebastian in the pitch." Voice actor? Yeah. In those movies?
Yeah, it's maybe a sound like it, but it's
somebody else. Make it sound like somebody else, yes. Artificial intelligence is responsible for that. Question. No, it will not sound like him. Right? Its twin will sound different from me. Right? That is interesting of how God made it all, right? This is how God made it. This twin is a different person. Even though they might look the same, still a different person. And because the twin is a different person, the twin is going to have a different fingerprint. Right? He's going to speak differently too. Right? Face ID? Right. Right? Because right, they know what you look like. They already know what you look like. Alright? So you all can imagine. And this is a gem I will leave you all with to go home with, right? And this is what I've been able to contribute. You guys are going to be the contributors of the future, right? But imagine, and they just rob the banks and so on in mass. Yeah. Right? So they go around robbing the bank and thing now. Camera record them. But because their face not showing, we don't know who it is. Right? What if we make artificial intelligence, right? They look at the footage, and when they walk, it extracts the biometrics of the motion. Yes. So all the police had to do now is identify the suspects and send them to walk in front of the computer. And when they walk now, the computer just extracts the biometrics of the motion and match it on the video and say, "Look, the man here that shoot the people around the bank." And we catch him. So you see how computers and technology is going to make the world a better place. And here it is. Everything I just spoke to you about, right, already exists. I made it myself. Right? I made it myself. Right? And that was my master's work. Right? That's when I did my master's. Right? So you guys, go ahead, be inspired. Don't come back. tomorrow. Right? Make sure you have the computers. Make sure you're ready. Talk to your parents about the exciting possibilities of the future, right? And this thing, artificial intelligence. Okay, guys? Make sure, right, you all are refreshed and come back tomorrow to learn. Right? Bye, guys. Huh? Yeah, I had a question.
Sereno. Anche di posso volare.